Hello everyone, this is Sharia. This is our second tutorial of Bitset, comprehensive of C++, all our header. So, so this is our example 6. In the 5 of the example we are covered in the first part. So this is our second part. So let's get started our video. So this is our second, sixth example. So in this example we are comparing two standard two bitset instance. Okay, so this is our first instance, second instance, third instance. We just compare these two b1 and b2 are equal. So this is, we can see these are equal, and b1 or b3 is not equal. This is, you can see this is not equal, so that's why this is called me the answer of the 2. So if we run that, okay, if we run that and see, then this will be the our one, that means true. Okay, okay, so now this is our 7th example. Okay, okay, this is a simple for loop, just to print this to one by one to the index size. So you can see the custom print that size t, that is the size of the I, and we can compare it to our bit size like b, and is the size that 8. Okay, then we can here increase it and we can see out it. Okay, we'll see out is I also the bi index. Okay, so if we run that, if we run it, okay, if we run it and see it. Okay, so this is our output. Okay, so this is our one of the most important topic to the example 8, to the binary addition. So our most of the case we are compare this or finding this how to solve the binary addition to this program. Okay, so here you can see our two bit set. Okay, b1 and b2. Also we can perform a binary addition in this criteria, also our while loop, so we can perform it also. Here you can see our right side is the whiteboard, then we can write it. Also you can see our note, also the first part, also second part, first part note we also uh, put in the course title that you can find it. Okay, so first, in this lecture or in this particular example we are only cover only 4 bit. Okay, because rest of the 4 in 8 bit, rest of the 4 is in this case are 0, so we just compare it to the word. Okay, so first we create a two box or two address. Okay, two address, sorry. Okay, so this is our b1, this is our b2. Also this is a example called 8. Okay, this is a example, this is example 8. Okay, now we have a index 0, 1, 2 and 3. Okay, this is our 4 bit. Okay, 0, 1, 2 and 3. Okay, in the first b1 we have a we have a 1, 0, 1, 1, and our bit 2. Okay, bit 2 is 1 1 0 and 1. Okay, this is our 2-bit. Okay, so just we simplify our code. We just shortly determine our XOR, also this carry, result or carry. Okay, so our first to determine result. Okay, so in the simplify that, we just write our first alphabet called R to find our result in the XOR. Okay, so we know that in the XOR position the same bit will be the 0 and different bit will be the 1. Okay, so our first bit and first bit will be the same, that we can cover it to our 0, sorry, then we just call it to the 0. Okay, 0, and our second bit are different, then we can cover it 1, and our third bit are will be the different, we can cover it 1, and our 4 bit are the same, then we can cover it to 0. Okay, now the carry time. Okay, now this is our carry. Okay, in the carry, so you can see in the OR position 1 will be the 1. Okay, 1 1 will be the 1, and 1 or 0 will be the 0, and 0 or 1 will be the 0, and 1 will be the 1. Also we can perform it with the left shift. Okay, left shift to the 1 position. Okay, so in the left shift to the clarify it. Okay, that we got some, in this case this will be our carry, then we can sum it to the 0 0 1 and 0. Okay, sorry, I have a mistake. Okay, let's define it. This is not a 0, that. Okay, 1 2 3 4, also 5 will be the 0. So in the left shift we can define 1 0 0 1 0. Okay, this is our left shift condition. Okay, so if here will be the same the right shift, then the 0 will be the left side. When it say the left shift, then will be the 0 will be the right side. Okay, this is most important. Okay, now to perform our this particular example, we have to cover a 3 step. Okay, 3 step. So okay, 3 step, we need a 3 step. Okay, our step number 1. Okay, step 1. Okay, so in this step 1 we have our temp, also our result in 0 1 1 0. Okay, and our carry will be the 1 0 0 1 and 0. Okay, now our first condition to result equal to result XOR carry, this is our condition. Okay, this is one condition, so let's perform it. Okay, so let's perform it to our result. Okay, result equal to, our first condition is to 0 1 1 0. Okay, 0 1 1 0 XOR 1 0 0 1 0. So let's define our answer. Okay, same bit same bit 0, same bit 0, okay, different bit 1, okay, same bit 0, and different bit we can assume it as a 0, so different bit will be the 1, okay. Now we can perform our carry operation, okay. See, carry operation, okay, carry operation, okay. Now here you can see our temp will be the 0 1 1 0, okay. Our carry will be the this, okay, this is our carry, okay, 1 0 0 1 0, and left shift 1, left shift 1, okay. So let's define it, okay, here let's define it, okay. So AND operation, 0 and 0 will be the 0, okay, and 1 and 1 will be the 1, 0 1 will be the 0, 0 0 will be the 0, 1 and 0 will be the 0, and if we left shift to the 1, then we can find it to the 0 0 1 0, also a 0, okay. This is our final output. So this is our final, and this is our final, this is our final result, and this is our final carry, okay. Now step 2, okay, step 2, step 2, okay. Now step 2, so our temp and result, temp and result are 1 0, sorry, 1 0 1 0 0, and our carry are carrier 0 0 1 0 and 0. So let's perform our second step to the R, okay, result. We are in loop 2 position, okay. Our result are to the 1 0 1 0 0, and this XOR operation 0 0 1 0 0. Now we can perform our XOR. Same will be the 0, okay, and same will be the 0, also same, sorry, same will be the 0, sorry, same will be the 0, and same will be the 0, and our different will be the 1, okay. This is our step 2 R result, okay. Then our carry, okay, carry. First we need a temp or result, 1 0 1 0 0, okay. Then our second hand position is our carry, okay, 0 0 1 0 0, also in a left shift 1, okay. then what will be the find? We can find it. Then you can see same will be the 0, and 0 0 will be the 0, 1 1 1 1. Okay, 1 1 will be the 1, 0 0 will be the 0, and 0 1 will be the 0. Okay, then we just left sheet. Okay, left sheet 1. Then what we can find? We can find 0 1 0 0 and 0. So this is our final carry. Now our final step. Now our final step to the step 3. Okay, now our final step to the step 3. Okay, step 3. Okay, step 3, temp and result. Okay, temp and result is 1 0 0 0 1 0 0 0 and 0, and our carry. Okay, carry will be the 0 1 0, sorry, 0 0 and 0. Okay, now we are performing our last and final. Okay, last and final result. Okay, last and final result. What will be the result? That we can XOR it. Okay, we can XOR it 1 0 0 0 0, and XOR it 0 1 0 0 and 0. So if we XOR it, then what we will find? 0 0 means 0. Okay, and this 0 0 means 0, and this 0 0 means 0, and 1 0 means 1. Okay, 1, and 0 1 means 1. Okay, this is our final this is our final output. Okay, and our final carry will be the 0 0 0 and 0, if you can determine it. Okay, here is our final output is the carry equal to 0. Okay, our program will be the stop stop or false. Okay, false here. Okay, so this is our final output, and the final output will be the look like this: 1 1 0 0 0 0 0 and 0. Okay, this is our final output. Okay, if we run that. Okay, if we run it. Okay, if we run it, and then we can set it, then you can find our final output result and this result. Okay, okay, fine. Okay, now we have another template. Okay, I can just remove it. Okay, now our another topic is the palindromic bits. Okay, what is the palindromic bit? It's like a mirror. Okay, it's like a mirror. We also define it. Okay, it's like a mirror. Okay, so here we just check it that this and this are palindromic. This and this are palindromic or not. Okay, so in this subconscious mind we can say that this is palindromic and this is not palindromic. So how we can define it, this is palindromic or this is not palindromic? Let's see our here to our droplet that we can define it how we can palindromic or not. So first we can header that this is our example 9. Okay, this is our example 9. Okay, this is our example 9. Okay, so to do that we need a call. So to do that we need a 8-bit bit set. Okay, first we need a 8-bit bit set. Okay, 0 1 2 3 4 5 6 and 7. Okay, so our bit will be the start with this to this. Okay, left side to right side, not the here. In the first tutorial we can define it why the bit start or index will start left or right, or less significant bit to most significant bit, most significant to less significant bit y please. So in this case we are start to left to right. Okay, so in this case palindromic case. Okay, so this is our 0 1 2 sorry 2 3 4 5 6 and 7. Okay, now our first position 1 0 0 0 0 0 0 and 1. Okay, this is our first bit set or b1. Okay, b1. Okay, this is our b1. So you can see our first we contain our bit set to the n, and what is the n size will be the 8. So n size will be the here n will be the 8 bit. Okay, then we need a n by 2 because we mirror this, because with that mirror this, that's why we need a sub 2. Okay, then we can just mirror this, we can just mirror it. Okay, then here why this logic? Okay, sometimes you may ask that I not understand or I may not understand how this logic will be performed. So just think of that how we can perform it. Okay, you can see the n when this position when bit I bit I is the 0. Okay, bit I is the 0, when bit I is the 0, and another is the this position right to left and right to left, then our next is n minus I. Okay, sorry, our n minus I minus 1. So how you can define it? Like a 8 minus 0 minus 1. So how you can define it? That it is 0. Then it check that 0 position and the 7 position is okay. So you can see that 0 position and 7 position are absolutely same. Then you can perform our palindromic. So rest our 2 3 and 4 5 6. How we can see that? If our I equal to 1, then our this case 8 minus 1 minus 1, then we can find our 6. So if we can see that our 6 number position and 1 number position also the same, so 1 and 6 also the same. So you can see that it is perform our same. Okay, then our third number position, okay, or second number position, or sorry, third number index, then 8 minus 2 minus 1 is to 5. Okay, then you can see that 2 also the same of 5. Okay, then rest of the that then all will be the defined. So we can say that this is palindromic. Okay, palindromic. But in this case you can see that this 1 and 1 will be the same, that in the our b2 first I 0 and equal to 0 equal to 7, then it perform a palindromy. But in this another case our 7 second bit, okay, that I2 that not perform a palindromic. Okay, that not perform a palindromic. Also I 3 this and this perform a palindromic. Okay, but the 4 and 4 are not a palindromic, so we can here consider it that b2 is not a palindromic. Okay, that's it. So if we see that and if we run that, okay, if we run that, then you can see one is palindromic and another is 0 or not palindromic. Okay, that's it. This is our another. Okay, this is another called representation permission using Bitset. Okay, this is as like our first tutorial that we can define it test or test. This is easy that how you can test it, that user dot upper test one, that one is key, one is 0, so this is a false. That if the test is 1, then we can say that it is 1, it is true. But in this case the test is 0 because the 0 of the index is the 0, but in this case will be the test will be the 1. Okay, then in this case our group dot permit in the test 0 will be the 0, then we can say that the test will be the 0. Okay, here you can see 0. Okay, okay, now we are go to the masking. Okay, this is another concept of programming language or low level language, that masking. So let's understand what is the masking. Here in the right side I just only show you the masking, how we can perform the masking. Okay, so see our it's also 29. Okay, so example 11. Okay, example 11, that masking. Okay, masking. Okay, masking. Here we can perform 3 type of masking called AND operation. Okay, AND and masking, okay, or masking, and X or masking. Okay, to simplify that, in the first section, okay, in the first section we just know that in the AND operation 0 will be the same, okay, 0 will be the same and 0 will be the same as like it is, and rest rest will non-masking, okay, rest will non rest will non rest will non-masking, I say again, non-masking will same, rest non-masking will same, okay. So in the or operation 1 will be the same, 1 will be the same, and rest bit, okay, rest bit non masking are same, okay. Now in the XOR condition, okay, XOR condition 1 will same, 1 or fourth one will be the same, and rest bit, okay, rest bit will toggle, okay, T O Z L E, rest bit will be the toggle, this is, so rest bit will be the toggle. So this is our main core concept, okay. So in these three core concept we can perform any of the X, AND, or an XOR operation in masking, okay. Here you can see our AND operation. So in this AND operation 0 0 0 will be the same, so 0 0 will be the same, and rest non-masking, this is masking, this is non-masking, rest non-masking will be the same. So we can find it, our original bit is this and the non-masking is 0 0 0 0 0 0 0 0. So we can run it, okay, here we can run it and see it, this is our output, okay. So this 8 this 12, this is another rotation. So this is your home task, you can perform it and just message me or comment me that you can find the exact answer like that, okay. This is your home task to the rotate operation, this is as likely same to the first few of this we can determine, this is a left shift and right shift, and you can call me if you cannot understand, I will definitely make a different video to that, okay. So finding our first set and answer, this is the same as it is, okay. So So let's define it. So find our first one. Okay, so in the first we can say that if the string operation, that will be the our most significant bit will be the priority first. Okay, okay, if the set reset, then will be the less significant will be the priority first. So here just create a call example. Okay, example 13. Okay, example 13. Then we create a memory, sorry, we create a memory, then you can define it 1 2 3 4 5 6 7 0 1 2 3 4 5 6 7. Okay, so in the string operation, in string bit manipulation, the index will be the start 1 to here and will be the 7. Okay, or 1 to 8. Okay. Sorry, 0 to 7 start here, and this will be the 8 bit. Okay, so our bit will has 1 0 1 0 1 0 0 and 0. Okay, now to find one, let's set to the set 1. We can see our first set of the bit of the index, first set. Okay, so first set in 1, that here 0 and 1 will be the 0. Okay, you can see the 0 and find to the 0, in the 0 will be the 1. Okay, then will be the 1, and you can see the first unset bit. Okay, the unset bit of the index, so unset bit of the index will be the 0. So 0 will be the here, also here, unset will be the here and here. Okay, unset bit, so we can get 1 2 3. So our unset bit index will be the 3, and I am it here very much little configuration, sorry, misconcept that we can find 1, that we can find 1 number position is the 0 and the 0. Okay, then we can find a 1 0, find 0. Okay, this is our 0, and the 0 position, what you can see, unset. Okay, 0 position, we can see the 0 position will be the 1. So if we run it, okay, if we run it and see it, okay, this is a 1. This is a very confusion, that I can assume that this is a 1 not 3. You can see, you guys, sorry, you can see here our 0 number index is 1. Okay, index will be the 1. Okay, 0 index will be the 1. So just to know other, we can just comment it. Okay, okay, I comment it later. Okay, so this is okay. Okay, now this is bitwise our 14 example bitwise operation on multiple. Okay, this is your home task that you can perform it. This is an easy home task that you can perform it. If you follow our 2 video, then you can perform it to the OR and XOR and AND operation. Okay, okay, then our last and final, this is a simple bit set data structure. Okay, This is the object oriented or OOP example. Okay, okay, let's see. So you can see we have a class called Bitset, then we have a public property, then we have a public property. We also inherit our bit size. Okay, we also inherit our bit size. Okay, then we create a add function, we create a remove function, we had a create a container function, and in the add function we create our return type and our return type and our return type. Okay, this is our return type. Okay, then we have a public private property this like, and this will be the inherit this. Okay, size is 32-bit and this size is 32-bit. Okay, then we just cover bitset, and okay, then we just call our class here. Okay, then we just call our class that bitset, then we create a object called set, and this will be the 32. Okay, then is 32, we add a 5, we add a 10, we add a 15, then we set out our everything. Also we can perform our set remove here. Okay, this is our output. Okay, if we run that, this is very simple, you can perform it. Okay, this is our answer. Okay, then this is another our some of the bitset project. uh, you can perform it, our bitset project, the subnet mask validation. This is a subnet mask validation. Okay, this is a subnet mask validation. So here you can see we create a function. This is our function body, and in this function we create our string reference called binary subnet. Then we can create our subnet, then we can set it our false, then we can logic it. It will be the start will initial value 7, then we can gradually decrease it. It will be the same as like like this. Okay, it will be the same like this, our example 9. Okay, then we just perform it. Okay, this is another project called custom binary encryption. Okay, this is another project called custom binary encryption. So this is our function, user defined function, and we create a encryption data, and we also create our bit set, also a string called empty. Okay, sorry, bit called empty. This is a result called empty, and this is our operation. Okay, this will be the same, will be the example 9. Okay, then here our operation. Okay, this is another project called efficient prime number. Okay, and we also some IP address validation. Okay, you can see it. Okay, IP address validation. Okay, thank you all.